My name is Sastré-Cordova. I'm a senior principal systems engineer, and I work for Raytheon Company in Portsmouth, Rhode Island. So Raytheon delivers systems and solutions for the warfighters, both domestically and internationally. Here in the Sea Power Capability Center, we primarily deal with our Navy customer and keeping our warfighter and soldiers and sailors safe. We build electronic systems, sonar systems, and sensor systems that actually are used by our military domestically and all around the world. As a kid, daydreamer type of guy, not particularly talented, I would say, anything, until I was in high school and I learned that science fair was something that I enjoyed doing. The first time I worked on a project, actually, I won, and that was, oh, all right, maybe I can do this. Other students that were successful in science fair became role models. This guy is a cool guy, he's good at science fair, he won first place, and you kind of want to, I want to be like him, or I want to be like her. When you graduate out of college, you come out with a good set of tools, and tools that you don't know if you're going to use right away. Skills that I learned in undergrad and calculus that I thought I was never going to apply again, it came up, and well, that now is a chance to apply that. I never let that go. I always wanted to build upon what I've learned before. I never thought I was going to be employed as a system engineer. My career path started in physics, and then I went to do oceanography, and I got interested in the technology that oceanographers use, and that brought me to look for a job in engineering. And Raytheon at the time was recruiting for this site, and in a job fair, and I got offered a job as a systems engineer. I didn't even know what that meant. As a systems engineer, we sometimes say that we master in breadth rather than in depth. We understand enough about the different disciplines, electrical, mechanical, software, electro-optical, and have the domain expertise to put systems together at the big picture, and then work with the different disciplines to integrate and make it happen. I get to analyze tough problems, and I get to look at data and make sense of it, make graphs and present it. And that's what keeps me coming to work every day. I think the most important skill you learn is how to pursue information. Most of the problems we face here are actually nothing that you can find in a textbook. Sometimes things are pretty new. That this has never been done before, so we don't know what the science is, or we don't know what the engineering is. For example, accuracy of sensors on the system. We've had issues where systems are not measuring the right thing or not measuring it accurately enough. Those problems usually fall on my lap, and they say, okay, go figure this one out, and I have to go ahead and dig down the system, talk to the software guys, talk to the electrical guys, think about what is it that we're trying to solve here, and get to the root of the problem. It's really about learning how to think, how to solve how to approach a problem, not necessarily applying a recipe to solving an old problem. I always say play to your strengths, play to, stay, if you want to be working technology and be technical, just play to that and let your peers know that that's where you want to go. So you end up in a path that you'll be happy in. And if you're happy doing what you're doing, then you're going to come up to do it every day.